A force is defined as a push or a pull. A force can cause an object to speed up, slow down, change direction, or change shape. Force is measured in newtons, abbreviated as N, and is measured with a Newton meter. There are different types of force, including contact, tension, friction, electrostatic, and gravitational forces. Contact force occurs when bodies touch due to repulsive molecular forces. Tension is the force in a stretched body due to attractive molecular forces. Forces always occur in pairs. When two bodies interact, the forces they exert on each other are always equal and opposite. Friction is a force in action that enables a car to move forwards between its tires and the road. The force of friction of the road on the tire is equal, but in the opposite direction, to the force of friction of the tire on the road. In rocket flight, there are a pair of forces. A is the thrust of the rocket engines downwards on the ejected gases. B is the contact push of the ejected gases upwards on the rocket engines. These forces are equal and opposite. Let's review the key terms in this video. A force is a push or a pull, and it can cause an object to accelerate or change shape. Force is measured in newtons with a Newton meter. Contact force occurs when two bodies touch. Forces always occur in pairs. A force exerted on an object will have an equal, opposite force. Now use your textbook to answer the questions listed here regarding forces between objects. Here are the answers to the questions. For the in-text questions, answers include 50 N upwards, 200 N, and that the wheels slip on the ground. For the summary questions, answers include equal and opposite, downwards and upwards, 500 N downwards, and 500 N upwards. The resultant force is the single force that can replace a number of forces acting on a body while having the same effect. In this example, the 2-3N and 2N forces acting in the same direction can be replaced by a single resultant force of 5N. In the cases below, we determine the resultant force by adding or subtracting forces in the same plane. When forces are equal and opposite, there is no resultant force. When the resultant force is zero, the object will remain at rest or continue to move at a constant velocity. If the resultant force is greater than zero, the object will accelerate in the direction of the force. In example 1, the box moves when the man's push force is greater than the friction force. In example 2, the plane accelerates when the engine force is greater than the drag force. In example 3, the brakes exert a resultant force opposite to the car's motion, causing deceleration. In example 4, the glider moves at a constant velocity because it has a nearly zero horizontal resultant force. Let's review the terms. A single force, called resultant force, can replace a number of forces. If the resultant force is zero, the body will remain at rest or move at a constant velocity. If the resultant force is in the same direction as motion, the object will accelerate. Braking decelerates a car because the force acts in the opposite direction to motion. These are the answers for the in-text and summary questions on resultant force. Review these answers against your own work. Force, mass, and acceleration of an object are related by the equation. Resultant force equals mass multiplied by acceleration. Resultant force is measured in newtons, N, mass in kilograms, kilogram, and acceleration in meters per second squared, meter per square second. This fundamental equation can be rearranged. Acceleration equals resultant force divided by mass. Mass equals resultant force divided by acceleration. This force triangle helps visualize these relationships. An experiment can be set up to check the relationship. The table of data shows that multiplying the mass by the acceleration results in a value equal to the resultant force, confirming the equation. Question 1. Calculate the force required to accelerate a car of mass 1,200 kilograms by 5 meters per square second. Using the equation, 1,200 kilograms multiplied by 5 meters per square second equals a force of 6,000 N. Question 2. Calculate the acceleration produced by a force of 200 N on a mass of 4 kilograms. Rearranging the equation, acceleration equals force divided by mass, or 200 N divided by 4 kilograms, resulting in an acceleration of 50 meters per square second. Question 3 requires 2 steps. First, calculate acceleration. Change in velocity divided by time, which is 6 meters per second divided by 3 seconds, resulting in 2 meters per square second. Second, calculate the force, mass multiplied by acceleration, which is 300 kilograms multiplied by 2 meters per square second, resulting in a force of 600 N. Now complete the following practice problems related to force, mass, and acceleration. The answers are provided in red for reference: 24N, 40 kilograms, 20 meters per square second, 2N, and 5,000 kilogram. Next, use your notes and textbook pages 136 and 137 to address these questions on force and acceleration. Here are the answers for the in-text and summary questions. Check your work. For example, in-text answers are 400 N and 4.0 meters per square second. Summary question answers cover concepts like resultant force, velocity, mass, and specific calculations. When a vehicle travels at a steady speed, the frictional forces balance the driving force, resulting in a zero resultant force. This state is called equilibrium. The total distance required to stop a car, or the stopping distance, is the sum of the thinking distance and the braking distance. Several factors affect stopping distance. Thinking distance increases with driver reaction time and car speed. Braking distance is affected by car speed, mass, road condition, and vehicle condition. Fill in the gaps using the word selection. When a car is moving at a steady speed, the engine force equals the resistive force. Stopping distance is thinking distance plus braking distance. Alcohol increases thinking distance. Doubling speed increases stopping distance by 4 times. Use your notes and textbook pages 138 and 139 to answer these questions about forces and stopping distances on the road. Review the answers for the on-the-road questions. In-text questions address car movement and stopping distances. Summary questions cover braking, thinking distance, and calculation examples. This section covers mass and weight. Mass is the amount of matter in an object, measured in kilograms. Weight is the force of gravity on an object, measured in newtons. The mass of an object is constant, but its weight changes depending on the gravitational field strength. Gravitational field strength measures how strong gravity is at a particular place, measured in newtons per kilogram, N per kilogram. Examples of gravitational field strength vary across celestial bodies. Weight can be calculated using the formula. Weight equals mass multiplied by gravitational field strength. Weight is in newtons, mass in kilograms, and gravitational field strength in newtons per kilogram. On Earth, a 1 kilogram mass has a weight of approximately 10 N. When an object falls through a fluid, such as air, the initial significant force is the downward pull of gravity. On Earth, it initially accelerates downwards at about 10 meters per square second. As an object speeds up, frictional forces like air resistance increase. Eventually, these frictional forces equal the object's weight, making the resultant force zero. The object then moves at a constant speed called terminal velocity. This graph illustrates the velocity-time relationship for a falling object. Velocity increases until it reaches terminal velocity, where the forces are balanced, and acceleration stops. A parachutist experiences 2 different terminal velocities. Before opening the parachute, it's about 60 meters per second. After opening the parachute, the increased drag force reduces the terminal velocity to about 5 meters per second. This velocity time graph shows the descent of a parachutist. It includes the initial acceleration, the first terminal velocity, the deceleration after opening the parachute, and the second, slower terminal velocity before reaching the ground. To summarize the concepts, weight is the force of gravity on an object. Gravitational field strength is the force per kilogram of mass, which is 10 N per kilogram on Earth. A falling object accelerates until frictional forces equal its weight, reaching its terminal velocity. Now, answer the questions based on the notes from pages 140 and 141 of your textbook. These cover mass, weight, gravitational field strength, and falling objects. Here are the answers to the in-text and summary questions. Check your solutions. The in-text answers include 200 N and an explanation of the resultant force becoming zero. You may use these virtual physics laboratory simulations to further explore force, acceleration, terminal velocity, and friction. Note that these links may only work in school. These are additional online simulations and revision links to help understand forces, motion, weight, friction, and terminal velocity concepts. Resources include PHET and BBC Bitesize. Next, answer questions 1 and 2 from pages 142 and 143 of your textbook regarding speed limits and related concepts. Review the answers for the speed limits questions. Answers cover acceleration of a ball, reasons for drug testing in athletics, research, and the 100 meters world record.